to tail rule or a head to tail rule, not head to tail rule. We find out the direction of a vector product or a cross product by right hand rule. What is the right hand rule? Let's start. Join the tail of vector A and B together. Join the tail of vector A and B together. It defines a plane. When we join the tail of vector A and the tail of vector B together, then it defines a plane. Okay, so first of all, join the tail of vector A and the tail of vector B together. It defines the plane of a vector. Place close fist of your right hand at a location where tail of two vectors are joined in such a way that fingertips show the rotation of a first vector A towards second vector B through a smaller angle. It means that when the two vectors still join it together, then we hold the vector in such a way that they will be first close together and show the rotation. Okay, so through smaller angles that show the rotation of a first vector A towards second vector B through a smaller angle. It means that smaller the angle will be close. Place close fist of your right hand at a location where the tails of two vectors are joined together in such a way that the fingertips show the rotation of a first vector A and toward the second vector B through the smaller angle. Erect means that straight. Erect thumb indicate the direction of cross product to vector A cross B or a vector product. Okay guys, so next is this is the A vector and this is B vector, and it is the tail which is the joined together, and it is the direction of a, and erect thumb will indicate the direction of a cross product vector. Examples. What are the example of a cross product and the second is vector product? Torque is equal to the cross. It's pronounced as torque. Torque is equal to the cross product of position vector R and the vector F. Torque is equal to the cross product of force F applied on a rigid body at a point whose position vector is R. Torque is equal to the cross product of a force F on a rigid body acting on a rigid body and at a point where the position vector is R. So RF sine of theta, when we change the R cross F into a simple their magnitude, so we will get R magnitude, F unit vector, F magnitude, and sine of theta, and is the unit vector which shows the direction of torque. So first definition is torque, second is cross product definition due to momentum, angular momentum. Cross product of a linear momentum P, the cross product of a linear momentum P and the position vector R is equal to the angular momentum. Simple that L is equal to RP, where R is the position vector and P is the linear momentum, which is MV. R, P, sine of theta, and unit vector, which show the direction of a vector. So these are the two examples, torque and angular momentum. Next is characteristics of a cross product. What is the characteristics of a cross product? So these let's start. Cross product is a non-commutative. It means that A cross B is not equal to B cross A because the result is different from each other. Cross product A cross, we know that A cross B is equal to magnitude of vector A and magnitude of vector B sine of theta plus positive and unit vector, which is the direction upward, positive, and downward is the negative direction of A cross B vector. So similarly that B cross A is equal to minus n. So it is proved that A cross B is not equal to B cross A, and the second result is that A cross B is equal to minus B cross A. It's mean that it is that the cross product is a non-commutative.